Welcome to video number 4 in the NLP sentiment analysis series. In this part, the part 3, we are going to apply the knife Bayes algorithm to the vectors which we got after applying the bag of words model to our restaurant reviews. So those restaurant reviews were in English words, and we converted that into a numerical variable, which was a numpy array, and now we are going to supply that numpy array to knife Bayes algorithm and see what kind of predictions can that algorithm give us. Knife Bayes is a classification algorithm. What we want to achieve is whenever we supply a new review to our classification model, it should be able to predict whether that review is a positive review or a negative review. For this purpose, first we'll be looking at how to split our data set into a training set and a test set. So sklearn's model selection provides a function called train test split. Here we specify a few parameters like the independent features x, the dependent features y, the test size. The test size means what percentage of the data set do you want to keep as test set. So 0.2 means that 20% of my data set will be used as test set. Random state equal to 0 means if you were to use the same code on your machine, I would get similar results to what I would get. The split would be the same. So random state equal to 0 will ensure that my results match your results. After this, applying the knife Bayes algorithm in this notebook, we are going to go ahead after splitting and import the knife Bayes class over here. Before that, let me show you xtrain, ytrain. So xtrain is a numpy array, ytrain is a numpy array. So our xtest and ytest. Xtrain, the length of xtrain, ytrain is 800 because 800 records have been taken as training set and 200 records have been taken as test set. Xtest over here shows you the array. It's basically an array of arrays. Every review has its own array. So if we have 800 reviews over here, we have 800 vectors within this array, and every vector contains numbers. Mostly you can see zeros over here, but wherever that particular word is present, we have a corresponding one there. So if for the first review, if it was wow, loved, and place, for the first review there would be 3 ones in the vector for review number 1. So if I were to write xtest 0 and I would check the length first, the length would be 1566 because there are 1566 unique words in our corpus, and every vector contains 1566 numbers. For the first review, there would be only 3 ones, and the remaining 1563 values would be 0. Alright, ytest is a variable which tells us whether the review is a positive review or a negative review. These are the actual values. These are before we apply the Gaussian NB class, the knife Bayes algorithm, to our data set. Now the goal is to use knife Bayes, fit knife Bayes on our data set, and use that model further to check whether the test set values that we have taken in xtest, do they give us the same predicted values as we have in ytest. So now I'm importing the Gaussian NB class from sklearn.knifeBayes. Classifier equals to Gaussian NB creates an object of that class, and in that object, in Gaussian NB class, we have a method called fit. Classifier.fit will take 2 parameters, the xtrain and the ytrain, the independent variable and the dependent variable. Bypred equal to classifier.predict xtest, basically taking all the values from xtest and predicting on those values whether the review is a positive review or a negative review. Next line here says print np.concatenate, and it has 2 values inside bypred, dot reshape and x test, y test and y pred. Y pred is the values that we have just predicted using the Gaussian NB class, and y test is y test contains the actual values of whether the review is positive or negative. For the first three values here, you can see that my model predicts that the review is a positive review, but the actual values in y-test show that that review is negative, and that's why we have a 0 corresponding to R1. So for the first three reviews, our prediction is incorrect. For the next two reviews, our prediction is correct because both y-test and y-pred contain 0. Again, for the next review over here, 1 0, my model gives the wrong prediction. So how many of these are wrong and how many of these are right? To check that, we use sklearn metrics and import two functions, confusion matrix and accuracy score. The confusion matrix will tell us how many of our predicted values are false positives, false negatives, and even true positives and true negatives. Now, this vector, this matrix here shows us that 55 plus 91 predictions are correct. So 55 plus 91, these are the true positives and true negatives, whereas 42 and 12 are the true negatives and the false positives and the false negatives. So 54 false positives plus false negatives, and the accuracy that we get on this is 73%, 0.73. And yes, that's it. Let us look at slight confusion regarding the structure of the confusion matrix. All right, so it's true positives, true negatives, false positives, false negatives. So we have 55 true positives, 91 true negatives, 42 false positives, and 12 false negatives. So this model is giving us an accuracy of 73%. Now we will look at SVM, kernel SVM, logistic regression, and a couple of more algorithms and check which classifier fits the best. All this content coming your way in the next videos. Thank you.